the electrode. So during electrophoresis, as we are interested in separation and characterization of the molecules which are undergoing the migration under the effect of electric field, we essentially don't allow the molecules to reach to the oppositely charged electrodes. Because if they reach, they will undergo electrolysis and lose the molecule. So that is the purpose. Then after understanding this concept of electrophoresis, we actually started to understand something about the theory of electrophoresis. And while understanding the theory of electrophoresis, we actually arrived at a relation which can let one understand that how the migration of any charged entity under the effect of electric field can be judged, and what are the factors which are going to affect the migration of the molecule. Okay, so that is what our just give me. Okay, so we arrived at this relation which you can see on your screen, and after arriving at the final relation for electrophoretic mobility, we understood that what are the factors on which the electrophoretic mobility of a charged entity is decided. So we understood certain inherent factors like the charge of the molecule or the particle, which is obviously dependent upon the pH of the medium. We also talked about how size of the molecule is going to affect the electrophoretic mobility. And finally, we also talked about the shape parameter, that how different shapes of a molecule with same mass might affect the electrophoretic mobility of any molecule under the effect of electric field. So these were the inherent characters associated with the molecule that will affect the migration of the charged entity under the effect of electric field. But apart from that, there are more than these inherent molecular characters. There are certain external factors as well which affect the electrophoretic mobility of the molecule, and that's what we were discussing in our last class. So this class has to do more with the external factors, in which we actually started discussing something about the voltage or potential difference is applied for electrophoretic migration of the molecule of our interest. And we developed this concept of voltage or potential difference, and how change in the distance of the two electrodes, which are placed at the same value of potential, what were there in the previous situation, which is shown on this triangle. If we don't change the potential values, but if we change the distance between the two electrodes, how the slope changes, and hence how the speed of migration of a charged molecule will get affected just by changing the distance between the two electrodes. So when we talk about the applied field strength, we need to consider both these factors. That's what was the purpose behind understanding this this aspect or this factor which is going to control electrophoretic mobility. So voltage is one. So now I believe that the understanding related to voltage is clear enough in everyone's mind. Next thing is about current. Now, when we talk about movement of charge from one electrode to other electrode, the velocity with which the charge moves, or the number of charges. You can put it like this, the frequency, you can say. Number of charges moving between the two electrodes per unit time is nothing but the current. Or it can be put it like number of charges reaching the two electrodes per unit time is described as the current. Now, what do you feel? How is the potential difference value associated with current? If you have understood the concept of potential difference, can you find out a relation between potential difference and current? Yes? Anyone?
Directly proportional.
Yes, they are directly proportional to each other. So what it means is that when I increase the voltage, there will be increase in current, correct?
Yes.
Yes, but is there any other, what you can say, uh, parameter that can affect this direct relationship, according to you? These are all things that we have already discussed. Now, why I have shown it here again is because these are the charged entities which are going to be reaching the electrodes. Now, mind you, do you remember this? At the start itself, I told you that when we talk about electrophoresis, we don't allow the molecule which is moving under the effect of electric field, we don't allow that molecule to reach to the electrode, right? So the charges on those molecules are never going to reach to the electrode, because as they reach to the electrode, that will undergo electrolysis, and electrolysis will completely destroy the molecule, correct? So our purpose during electrophoresis is that we just want that the molecule should carry the charge, move under the effect of electric field without reaching the electrode. We'll stop the migration before the molecule reaches to the electrode. So what are those entities which are going to be involved in generation of current during electrophoresis? So to make you understand that aspect of electrophoresis, this is what is shown over here. It's basically electrolysis of water. And apart from electrolysis only, as there are buffer ions which act as just like electrolytes, these ions will be reaching the respective electrodes depending upon their charge status. So what do you think, if you increase the potential difference, will there be increase in current now with this understanding about electrophoretic procedure? Does it seem to be directly proportional during electrophoresis? Am I making the question clear enough for you to understand? Okay, Janki says yes. But what about the answer? Can you predict the answer now? Will the current, now we understand current as the number of charges reaching to the electrodes. And during electrophoresis, we don't allow our molecule of interest, which is the charged entity, to reach to the electrodes, right? We have to stop it before they reach to the electrode. So then, will this direct relationship of voltage with current be still obeyed? Is it a fair question to ask? Yes? Do you want me to repeat the question again for you? Or is it fine? You are thinking about the answer. Yes? Okay, thinking about the answer. So anyhow, can there be now a direct relationship, or there must be something now which can control the amount of current generated? As we have already understood this as the aspect of electrophoresis, that these are the mostly the charge will be carried by the buffer ions, and the macromolecules will just be allowed to carry the charge, but they will never reach the electrode. So now, is it a fair question to ask that if I increase the voltage during electrophoresis, will the current be proportionally increasing, or will it not? Yes, I want some responses from your side, just to make me understand that whether you are getting the point clearly or not. Okay, Janki says it will increase. Okay, so I want to know from others as well that what do you think? It will increase or it will not increase? See, now most of you must be having this concept of Ohm's law, right? Heard about Ohm's law? And what does that say? That voltage is equal to current provided you keep resistance constant, right? Meaning, I can say this like voltage is directly proportional to current. So whenever voltage increases, current should also increase, provided resistance is kept constant. Can I say this? And if I can, then what is going to be responsible for the resistance value during electrophoresis? We have already discussed this. So I am interested in finding out whether you still remember the concept or not. Yes? So what will be the deciding factor that will control resistance here? Or what will be the resistance determining factor? If I want to put it like this. Yes, anyone? This is basically resistance to the flow of current. Now, the buffer ions which are moving and are responsible for carrying the current to the respective electrodes, those buffer ions are going to feel the resistance of movement because of what? We have already discussed this, right? So whenever a molecule of your interest is moving under the effect of electric field to its oppositely charged electrode, then it is not going to pass other molecules just like that, right? There will be some degree of friction happening. And this frictional component is pretty important here, because that will be causing the extent of resistance. So now that depends upon certain aspects, like that depends upon uh, yes, Sarvesh wants to say something. He has written resistance, but yes, a frictional force which is acting against the mobility of every charged entity under the effect of electric field will be essentially responsible for resistance. So, do you believe this now? That if I increase the voltage, there will be increase in resistance or decrease in resistance? Can I put it like this as well? Okay. You say, okay, Janki says decrease in resistance. That's a bit tricky. Okay. I can put it like this as well, looking at Ohm's law. Can I not say this? That voltage is directly proportional to resistance as well if I keep current constant. So if I increase voltage, can I not see increase in resistance? If current is same? Yes. So then if at all, it will be fair to say this now, that if I increase voltage, there will be a proportional increase in current as well as resistance, right? And if resistance increases, there is a big problem for you all. Now, what's that problem? Okay, resistance is actually going to retard the movement of molecules and hence is going to affect the current in an adverse way. And because the current is going to get affected, you are not going to get effective separation. So there has to be some way by the way of which you can actually control resistance. Okay. And because resistance is majorly because of the frictional coefficient, which is going to be associated with any charged entity that is moving under the effect of electric field, this frictional component leads to another factor, and that factor is actually associated with heat generation or power generation. Because now there is another concept that is coming into play. Now we have talked only about applied field. Okay, we have talked about components of applied field, which majorly involves potential difference, which will decide the what you can say, the speed with which the ions are going to get conducted between the two electrodes. And at the same point of time, we also have talked about that because ion conduction or the charge conduction is majorly taken care of by buffer ions, the mobility of these buffer ions are also going to get affected because of the frictional coefficient. And that leads to what is called as heat generation. Now imagine this situation. Okay. And I have given this relation also for you. Okay. Now it will be slightly complicated now because we are taking or considering several things at a time. Okay. Quickly, can you tell me this, that if I increase by say for hook or crook, I increase the temperature of the medium in which electrophoresis is carried out, what will happen to resistance? Will it increase or decrease? Okay, survey says increase. How many of you believe that resistance will increase if there is increase in the temperature of the medium in which electrophoresis is carried out? How many of you believe this? Okay, Janki also says that it will increase. What do you think will happen to viscosity of the medium when temperature increases? Increase in temperature, what's the effect on viscosity? Imagine that you have something viscous with you and you are increasing the temperature. What happens? Will the viscosity increase with increasing temperature or decrease with increasing temperature? Viscosity will decrease, right? And in what way viscosity is related with electrophoretic mobility? If you want, I can show you the relation. It's inversely proportional, right? So if viscosity decreases with increase in temperature, what do you expect to happen to electrophoretic mobility? Decrease in viscosity due to increase in temperature. Electrophoretic mobility will be more or less, electrophoretic mobility will also increase, right? So will you get a better separation? Is it a fair question to ask now with the analogy that we have built up? Is it a fair question to ask that will we get a better separation? Survey says yes. How many of you believe that you will get a better separation with increase in temperature, decrease in viscosity due to increase in the electrophoretic mobility? How many of you believe that you will get a better separation? Yes. Because there will be more power generation, right? Because with change in temperature, what will happen is that the power will be basically dissipated in the form of heat, right? Now, I'm correlating this with the previously developed concept of voltage. So I increase the voltage, there will be increase in current. Increase in current will lead to more power generation, and power generation is dissipated in the form of heat. So what will happen to resistance according to you now? Because there is low viscosity, what will happen to resistance? Yes, anyone? Resistance will increase or decrease? Come on. So what we have done till now, okay. Voltage increase will increase the current. Current is directly proportional to power, right? Power generation. Power generation is directly proportional to heat generation. Heat is inversely proportional to viscosity, correct? So if there is more current due to more voltage, there will be less viscosity and greater electrophoretic mobility. What will happen to resistance according to you now? Which is because of the frictional component. Will it increase or decrease? Resistance will decrease. Okay, Sarvesh. Now analyze your own response previously. Sarvesh, what did you say about resistance when I asked about the power? You said it will increase. Now you are saying that it is going to decrease. Why this change? Now, once you answer this, then perhaps I will put up another question for you in order to find out that will you get a good separation? Because that's what is the purpose of all this, right? What we are trying to do here is we should be able to make the molecules of our interest migrate under the effect of electric field and give us a good separation. That's what is the purpose, entire purpose. Now, whatever is happening, heat is getting generated due to increased voltage, right? And because of heat increase, you will get increased mobility because of drop in viscosity. That's what is our anticipation. But actually, it doesn't happen like that. Okay. When there is increase in heat, then basically there happens evaporation of the medium liquid as well. Okay. And that increases the concentration of buffer ions in the solution. What that does is it adversely affects the mobility of your molecules under the effect of electric field. The reason is this: because buffer ions are very small, the proportion of charge to mass, if you compare of buffer ions with your molecules, which has a greater proportion of charge compared to the mass value? You have two options, buffer ions. Did you get the question, first of all? So what is the consequence that we are getting to with increase in voltage, with increase in current, with increase in power, with increase in temperature, that is heat generation? We expect that the resistance should decrease because of decrease in the viscosity of the medium with increase in temperature. But as soon as the temperature increases, this heat generation also leads to evaporation of the medium, the solvent of the medium. What that does is that it increases the concentration of buffer ions. Okay, and concentration of buffer ion increasing, will that mean that your sample is going to be carrying the charge more, or will the sample carry the charge less now, according to you? If you have got the situation correctly? Okay. If you want me to give you another perspective, let me take this chance now. Just a moment. Okay. So now just imagine this situation. Okay. That this is the size of buffer ions for you. This is a buffer ion with a charge. Obviously, I am not okay. I will give it a charge as well. So compare this as a positively charged buffer ion. Okay. And this is your sample molecule. It also has a charge. Now, according to you, when the concentration of buffer ions increase, several such positively charged molecules compared to your molecule, what will be carrying the current preferentially? Buffer ions or sample ions? Yes? See, previously when you began the process, say suppose there were 10 buffer ions per unit sample ion. So if there is one sample molecule, there are 10 buffer ions. Okay. Now, because of increase in power, because of increase in voltage, because of increase in temperature, what has happened is that instead of 10 buffer ions, you have got now 100 buffer ions because there was evaporation of the medium, and now the concentration has increased. Concentration of sample ions is still the same what you have added, right? Now, if you compare, what will carry the charge more? Will it be sample ions, or will there be buffer ions which will be carrying the charge more? Yes, any response? Obviously, now the proportion of charge carried will be much more by buffer ions. Now, if it is so, then more and more buffer ions are reaching the electrode per unit time. So current has increased, right? That is what has caused all this to happen. But now there is less proportion of sample ions migrating, just because the migration of sample ions is now facing more competition by buffer ions. So because sample ions are not migrating much, what happens is that instead of getting a sharp band, you get broadening of the separated samples. Broadening in the sense, what it means is that if this is one band of your sample, another sample was migrating very close to it, but because of broadening, they actually got mixed up together when there is increase in temperature. This also happens because of another factor, which is called as convection current. But I will not go into this right now. We will talk about convection current more when we understand the basic factors first. Okay. And obviously, we have talked about this situation already. Decrease in the buffer viscosity will cause reduction in resistance, and there will be more and more current now allowed. So basically, what is happening is that you have increased the voltage somehow in anticipation that there will be faster separation. But instead, what has happened is that there is increase in current, which has caused increase in power, which has increased the heat, which has caused the medium to become more concentrated for buffer ions because of evaporation. And because there are more buffer ions now, sample ions are getting less privilege of carrying the charge. So, will there be a good separation according to you? In all this situation, do you feel that there will be a good separation or there will be a bad separation? Yes, anybody? Have I complicated things for you more? Do you feel that there will be good separation now? Anybody? If you just increase the voltage. No, you will not get good separation, Janki. You will not get good separation just because with increase in voltage, everything has actually changed. You have increased the concentration of buffer ions, so there is no charge now available to be carried by sample ions. Imagine, these are quite fast, right? Electrophoretic separation as or electrophoretic velocity, we actually correlated it directly with mass to charge, if you remember. And mass to charge ratio of buffer ions is too large as compared to sample ions, right? And if mass to charge is better for buffer ions, then obviously you will, sorry, it's not mass to charge, it's actually charge to mass, sorry, charge to mass. So now if I talk about velocity of movement, and if I compare it with buffer ions are too small, so mass is very low and charge is very large. However, if I compare it with sample ions, then the charge is too low and mass is very large because sample ions are mostly macromolecules, bigger in size than buffer ions, right? So as I increase the voltage, as I increase the current, as the power automatically gets increased, there is heat generation, there is evaporation of the medium, buffer ion concentration increases. So more and more charge will be carried by buffer ions with less privilege for sample ions to carry the charge. So sample ions will hardly move, in other words. And because there is no mobility, there will be no good separation. You will not get good separation. That's what is given over here, broadening of the separated samples. Okay, there is one more factor that comes into play, but I don't want to complicate it even further for you. For time being, let us take into consideration that increase in voltage is not going to work for you. If you imagine that increase in voltage will speed up the process of separation, it will not. Okay, it will cause all this complication. So instead of increasing the voltage, it's always preferred that what you do is that you increase the current, keeping all these things constant. Okay, so how will you do it? You can do it by minimizing the heat production now. Okay, you increase the current, you expect that there will be more heat. But what if I put up a cooling system here? Can I do that? Yes. So whatever I expect now with increase in current due to increase in heat production, whatever complications that I have faced, to minimize them, what I do is that I carry out electrophoresis in a cooling condition. Okay. So if I do it in a cooling condition, there will be no heat production, or whatever amount of heat generated will be cooled down, right? So now if that is so, then nothing related to evaporation and sample, separated sample broadening, or change in the viscosity or change in resistance will be allowed. Now I can get a good separation, right? Do you agree? Yes. Okay. So that is how you minimize the generation of heat, and on that basis, you actually carry out a better separation. So one thing that you have to be very certain about is that when you uh, increase the voltage, you have to maintain either the current constant, or otherwise you make or you keep current constant and don't allow the rise in temperature. Okay. So whatever the things may be, you can stabilize the system by using voltage or a power system, a power pack that has a stabilized voltage or stabilized current system. On the way of which you can actually get rid of all these problems that we have discussed. So, although as we have already talked about, heat generation can be minimized by using a cooling system that can make the things happen better for you. Okay, whatever is possible, you can do it so that all these parameters are kept constant and you get a better separation. The most important aspect is that we will be requiring a better separation. Now, the next important factor that decides is the buffer system. And the buffer system, because it is going to decide the charge on your molecule. So there are different ways in which buffer can actually affect electrophoretic mobility. As we are actually nearing the end of the lecture, what I will do is that I will not discuss the buffer and the medium today. Perhaps we can discuss about the buffer and the medium tomorrow, as we paid much of an attention in the electric field today. But buffer is important because that is going to decide the pH, as well as that is going to decide the charge on your sample, and charge is going to be the essence for separation. So we will not talk about buffer and medium today in greater detail. We will talk about them in the next class. So if you have any doubts regarding today's session, then you can ask me right away. Yes, any doubts? Yes, anyone is having any doubts regarding today's session?